This is a video on definitions for Chapter 2. 2-1 starts with organizing data. First definition is raw data. So the data that is given to you in the book is called raw data, as in before you cleaned it, before you organized it, before you saw anything. Usually the first step in raw data is cleaning it. So getting rid of values that are wrong, organizing in an alphabetical order or from smallest to largest or some other way. Frequency distribution. Organization of raw data in a table form using classes and frequencies. So this is what we're going to be doing for most of the semester, is organizing things in tables. A categorical frequency distribution just means that your data isn't numbers. It can be categorized into categories. The example that I have is blood types, but really, different kinds of cars, they have names, so you can break this down into categories. Class limits. So you will see in the next examples that if you are breaking things down into frequency distributions, what you want to do is you want to organize things by classes. A class limit is where is all of the data points or numbers in your data set that you want to include in a specific class. So from the very beginning to the very end. The lower class limit is the smallest value that you want to include in that particular class. The upper class limit is the largest value that you want to include in that same class. The class width is the difference between two consecutive lower class limits. You will see this in the example in the next video. You want to take two consecutive classes, subtract either the lower class limits or the upper class limits. The key in the frequency distribution is to make sure that all of your classes have the same width. Otherwise, there's something wrong with your frequency distribution. Every class has a midpoint. This is the average between the lower limit and the upper limit. The formula is given under the definition. Class boundary. Every class or between two consecutive classes, there's a class boundary. In order to find a class boundary, you look at the upper class and the lower class of the next class, and you want to take the average. Again, this will be an example on the next video. Now, 2-2 has three graphs that we're going to be doing. All of those are examples in the videos to follow. A histogram displays the graphs in vertical bars that uses height as the frequency of the classes. The frequency polygon, it's the same data from the histogram, except we use the midpoints on the x-axis. The height is the frequency, and it's a line graph rather than a bar graph. An ogive is a cumulative frequency, and again, this is a line graph rather than a bar graph. At the very end of chapter 2-2, there is different shapes of distributions. On page 64, you can find more shapes, but what I wanted to do is I wanted to outline the ones that are most important and that we'll see the most in this semester. So shape number 1 is this one. It's a symmetric distribution. You can see symmetry if you draw the line right in the middle. It's sort of the left one looks very similar to the right one. It is a bell-shaped because if you approximate this with a smooth line, you do get a bell. And this is a normal or approximately normal distribution. And this is what we're going to be studying for most of the semester, is normal distribution. The reason I chose this picture is to illustrate an interesting fact. These bars are discrete, so they're distinct from one another. Yet what we're doing is we're taking a line and we are approximating something using a smooth curve. This is something that we're going to be doing in chapter 6. My next definition is left skewed. Sometimes it's called negatively skewed or skewed to the left. The reason it's called skewed to the left because what you want to do is you want to find the tallest tower and notice that there's a lot more bars on the left of the tallest tower than there are on the right. So this has a left tail, or a tail is to the left, so this is called left skewed or skewed to the left. This is a picture of a right skewed. Notice again, this is a tallest tower, and there is a lot more going on to the right of it, and the tail is all the way through. You can't really see it, but there's tiny, tiny little numbers way over there. So it is called skewed to the right or right skewed, and sometimes it's called positively skewed. A few more pictures. If you have a distribution that just sort of, it's all the same all through, we're going to call this a uniform distribution. And this one is bimodal. What I wanted you to see is there is a high peak over here, and there's another high peak over here. Sometimes it's called the U shape because that's what it does. But really, I want to articulate the fact that it has two high peaks. Therefore, we're going to call it bimodal.